It's now my great pleasure to introduce to you C.N.R. Rao. And Dr. Rao, congratulations, you are the MRS Von Hippel Award winner.
Thank you.
That is a big honor. It's the Society's highest honor, in fact. So tell us about your reaction to this award when you first heard that you'd won the Von Hippel.
Well, this is the highest award, as you said, and sitting somewhere in India, suddenly one day hearing this was something nice. I didn't expect this or something like that, because the people who have got it before me, or each one is a very big name in the field. Well, I have done as much as I could in the last 50, 60 years in research, but didn't mean that I would be picked as the winner.
You're in great company, rarefied air.
Very, very good company, yes.
You said you didn't even realize you had been nominated. You had heard months ago.
People had mentioned to me that they are thinking of nominating. I forgot about it. I didn't realize it was serious.
And then you heard you won.
Yeah.
And you believed it, or did you think it was?
Yeah, but of course, I believed it, because the president of the MRS was on the phone. She said, congratulations, we expect you to come here on 29th of November for the award.
And you knew it was the real deal.
That was the real deal.
That's fantastic. So your award talk is titled Glimpses of 6 Decades of Research in Materials Chemistry.
Right.
Obviously, that's a lot of ground to cover, but
there are two ways of looking at it.
Yeah.
You see, when we started research, or I started research in this area, the subject didn't exist. Hardly any, like any American university, went to Purdue, Berkeley, there's hardly any materials research, little groups. There was no department of material science anywhere I knew. So when I was a graduate student here, for example. So things have changed. So I grew up with this subject in the last 60 years. I therefore contributed to many aspects of this area. I thought it would be very nice to look at that past and how we came from nothing to what we are today. Amazing explosion of knowledge, information, lots of contribution. I thought I would talk about that.
That's a fact. Now, what are some of the most exciting developments, speaking of, that you've seen in materials research over your 6-decade career?
Well, in my own career, I used to work on what are known as transition metal oxides, their properties, all kinds of phenomena, applications. But suddenly one day, if you remember, in the end of 1986, high temperature superconductivity was discovered. I was one of the participants in that. I did a lot of work on high temperature superconductivity. I was one of the few people, other than the Bell Labs here, to make the first liquid nitrogen superconductor, which becomes superconducting at 90 Kelvin for the first time. Till now, the limit was 23 Kelvin. So that was a very big season. And since then, the equally exciting or sensational discovery was in 2004, 2005, graphene, 1 atom thick carbon sheets. Well, I immediately got into graphene because I always did work on carbon. But now I said, why graphene? Why not take many other inorganic sheet layered materials and make graphene-like structures? So I have done a lot of work on inorganic graphenes.
Obviously, as you said, a lot of developments, exponentially so.
And then, in fact, some of the inorganic graphene, like molybdenum sulfide, is more exciting than graphene today.
And I wanted to talk about that. What do you see as the future developments?
There are many applications. The applications in what you might call nanoelectronics of some sort, or catalysis, a number of areas where these materials are finding application, potential application. Some may become real soon. For example, using one of these sheets, I've been able to split water into hydrogen by using solar energy. So if you want to make lots of hydrogen for energy, you can use many of this kind of material.
Now, what do you see as some of the biggest challenges coming forward?
Well, I think humankind is facing very serious threats. The threats to its existence in the next 3-4 decades. Energy, environment are the two most important areas. So material science has much to contribute to energy as well as environment. I don't know, as we are talking, the carbon dioxide content in the air is increasing like fast.
Well, people have told me there's a lot of hot air in whatever room I go to.
Here it isn't so bad. You go to China or some of these countries, or even India, CO2 gases are unbelievable. So who is going to get rid of it? What are we going to do about this kind of pollution? How are we going to stop this pollution? For example, the oceans of the world, the acidity of the oceans has increased enormously in the last 5 years. I don't know if you know that. Lots of carbonates are getting precipitated, affecting the life in the oceans. I think we have a lot to do about two typical problems, and there are lots of solutions available through materials research.
Now, obviously, you have a lot of passion, so tell me about your love of science. When did that first start?
I tell you, when I was an undergraduate, I read a famous book on nature of the chemical bond by Linus Pauling, the great man from Caltech. I thought, this is the kind of research I want to do. This was in 1951. You can imagine, it's long ago, 60 and odd years ago. I wrote to him, in fact. He became my guru, as it were. So I did, for my PhD, research similar to what Linus Pauling did, but I worked with one of his students for my PhD here. Then I went to University of California, Berkeley, which was built by the great G.N. Lewis, the chemistry department. That was another wonderful stay. I think I was born academically in this country.
I think you
Though
were.
I was born in India physically, but academically and scientifically, I was born in this country.
You've had a fantastic career and a fascinating amount of research coming out of it. I want to thank you again and congratulate you one more time, the 2017 MRS Von Hippel Award winner, Dr. Rao. Great to meet you.
Thank you. Great. Thank you.